All right, fatty acid oxidation. So first we start out here in the cytoplasm, outside of the cell. Fatty acid comes and that gets turned into Acyl CoA. And that does that with help from the CoA enzyme that comes in, and then also ATP that comes in to help this change occur. So ATP goes in and comes out is a pyrophosphate group. So we'll leave it at PPI. Okay, so then from that point, let's step back. There's an enzyme that helps facilitate that. So the enzyme is Acyl CoA synthetase. All right, bingo. So from there, the Acyl CoA comes down and turns into acyl carnitine. All right, and then acyl carnitine, this happens because of the enzyme carnitine acyl transferase 1. And what else also gets thrown in here is carnitine. In there. So carnitine comes in, combines with the Acyl CoA, thanks to Cat1, turns to acyl carnitine. And now the substrate has to get through the membrane and into the mitochondrial matrix. So in order to get through the outer membrane, that's no big deal. That's relatively easy. Outer membrane's more permeable with this acyl carnitine. But while doing this, while coming in, we lose the coenzyme A. So we lose that goes out. And then it can't just freely go through the inner membrane of this cell, of this mitochondria. So it uses acyl carnitine translocase, which I believe is a protein, an enzyme that helps bring this acyl carnitine through this inner membrane and into the mitochondrial matrix. So it's broken through. As soon as it gets through, this coenzyme A reattaches. The coenzyme A that we lost up here ends up reattaching. So then this becomes, that enables this to still be acyl carnitine. Which there we are here. And acyl carnitine turns back into what we had up here, Acyl CoA. And through that process, it loses the carnitine. Lose the carnitine. And the carnitine actually goes back through the membrane in the cytoplasm to be reused again through this transfer through the membrane for the next Acyl CoA. Let me also mention a little step that I missed, is that for this CoA to be thrown back on the acyl carnitine, the enzyme carnitine acyl transferase 2, Cat2, is used. All right, so now we have this Acyl CoA, and this is the beginning of this four-step cycle, which is where beta oxidation happens. So we have Acyl CoA. Acyl CoA will turn into trans delta 2 acyl CoA. Long, drawn-out word. So this transfer from acyl CoA to trans delta 2 acyl CoA is facilitated by Acyl CoA dehydrogenase, and also an FAD is thrown in to help this, and we gain an FADH, which we'll use later in the process of making ATP. All right, so now I have this. This is also the first step of this 4-step process here. So this step is oxidation. So in the second step here, the trans delta 2 anyl CoA turns into L-beta hydroxyacyl CoA. All right, so then we got that to there. This is done using the enzyme anyl CoA hydratase. All right, and then also another thing to help this occur, this change in the L-beta hydroxyacyl CoA and H2O gets thrown into here, gets pulled in order to make this change. That's because the H2O is getting pulled in. This step 2 of the 4-step, is hydration. All right, so there we go. And then from L-beta hydroxyl CoA turns beta ketoacyl CoA. So we'll draw an arrow here. Almost finished with the cycle. So this change here, an enzyme L-hydroxyacyl CoA dehydrogenase is what helps this occur. Instead of using an FADH like up here, we're actually going to pull in an NAD, and we're going to gain an NADH, which will be used just like the FADH later in this in another cycle to create ATP. So you can see here in this one this is Acyl CoA dehydrogenase. This is also a dehydrogenase, which makes this third step oxidation, just like the first step. 3, 1, 2. So then, as you can see, 4 will occur up here. So the fourth step is where beta ketoacyl coenzyme A turns into acyl CoA, and also here this is known as the cleavage step 4, because this beta acyl CoA gets split and forms an acetyl CoA along with an acyl CoA. So this is done. Coenzyme A gets pulled in to help this occur, and the enzyme thiolase. Thiolase is used here to help this cleavage step occur. So then we have acetyl CoA, which can be used next to create more ATP, maybe in the Krebs cycle or another cycle. And then the rest, the acyl CoA gets thrown right back into this loop to start this process all over again. Now, one thing to note is that when this beta ketoacyl CoA gets split and turned in to acyl CoA, acetyl CoA takes two of the carbon molecules. So when this new acyl CoA comes in, it's -2 carbons. It's got 2 less than it would last time. So this molecule will keep going through this cycle until it's out of carbons. And then we have acetyl CoA as the byproduct, as an end product, so that'll get turned into energy later. NADH down here will get turned into ATP later. FADH here will get turned into ATP. So there we go. Fatty acid down outside the cytoplasm. Acylcarnitine gets split up through and ends up getting back together once it's through the membrane, and then this cycle begins. Using all these enzymes, all these substrates turn in, and we get Acyl CoA and Acetyl CoA, Acyl CoA at the end. So there we go.